Okay, we're still taking a look at inequalities. In 3.4e, we're going to be looking at something that I call compound inequalities. And what those are going to look like, what you see down below here, this in fact is what the answer to a compound inequality is going to look like. So I'm going to talk about that right at the beginning. We want our answer to look like where we have the variable in the middle, and then on the left the smaller number of the two, and on the right the larger number of the two, and the arrows are always going to be pointing in this direction. Whether or not you have the equals, it doesn't matter. The important thing is the arrows are going to point this way. Okay, let's take a look at these compound inequalities. What we see here in this compound inequality, it's basically saying two things. And as I mentioned before, mathematicians are lazy, so we want to say things as easily as possible. This is making two statements. It's saying this inequality holds and this inequality holds. So I've written those two down below, and the word that connects them is and. That means both of those have to be true. So let's do an experiment. I'm going to split them apart and see what happens to solve each of them, and see if we can't discover a shorter way to do these. So if we take a look at this first one, 13 less than 2x plus 5, what are we going to do to get x by itself? Well, we're first going to subtract 5 from both sides, and that's going to give us 8 less than 2x. What are we going to do over here on the other inequality to solve for x? I want to get that, subtract 5 from both sides. So again, I'm subtracting 5 from both sides to give me 2x less than 14. Now what are we going to do? I'm going to jump back over to the first one. To get x all by itself, well, I'm going to divide by 2. So divide by 2, and that's what we have. On the right, divide by 2 again. So we're doing the same thing on each of these. From this step to this step, we subtracted 5. From this step to this step, we divided by 2. So if we're going to be doing the same thing on both of these, why don't we just do it all together? The idea behind that is the following. So we're going to do this problem again, but we're not going to separate them. We're just going to try to do it all together. So you're used to me saying something about the two sides of an equation. Well, now we've got an inequality, and we can think of it as three sides. So we can do anything we want as long as we do the same thing to each of those three sides. So our attention is always on that x. We know we want x all by itself here in the middle. So we look at that and we go, well, what can we get rid of first? Well, let's get rid of that 5. How are we going to do it? Subtract 5. So we subtract 5 from everybody. 13 minus 5, 2x plus 5 minus 5, and 19 minus 5. And then our attention is still on getting that x all by itself. What's in the way? That 2, it's multiplying, so we know to divide. Divide everybody by 2. 4 less than x less than 7. And that is our final answer. And look at what we got before. X, so we've got 4 is less than x, and x is less than 7. Okay, so does that look like what we have here? 4 is less than x, and x is less than 7. So the moral of the story is, if you have a compound inequality, you're doing two jobs at once. Okay, let's take a look at another example. Okay, so we've got a compound inequality. Our attention is on that center because we want x all by itself. So what do? Well, let's get rid of that 7 first. And what's it doing? It's being subtracted, so we know to add 7 to everybody. So negative 4 plus 7 is a positive 3. Add that negative 7 in the middle, so that goes away. And 7 added to the 11 gives us 18. So now we're almost there. We've got x just with that little negative 3 in front, so we've got to divide everybody by negative 3. Ding, 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 ding. Did you hear that? we're dividing everybody by -3. So it still works that when we multiply or divide by a negative with an inequality, we have to change the direction. So let's start this. So 3 over here divided by -3 is going to be a -1. We got to change the direction of the inequality because we divided by a negative. In the center there, -3 divided by -3x divided by -3 gives us what we want, a positive x. And then the 18 divided by -3 is a -6. And we've got to change the direction. So now we know we want that x to stay in the middle, but we want the arrows to point the other way, and we want the smaller number down here and the larger number down here. So on a number line, here's -1, here's -6. So yeah, -6 is the smaller between, is the smaller of those two numbers. So we go, yep, -6, -1. And if you get confused, you can always, when you compare, when you take a look at how x compares to -6, the arrow is pointing towards the -6 as it is down here. And when you compare x and -1, the arrow is pointing at the x as it is down here. So our final answer looks like this. Now, let's graph it. Okay, we didn't graph the last one. I think we got to graph some here. What I love about this, what are the only two numbers we care about? -6, -1. They're already there on my graph. And in this form here, I see, well, x lies between those. And on your graph, the numbers that work are going to lie between those two. And then you have to decide, do we want an open or a closed circle? Well, since this is less than, we want open. Since this is less than, we want open. So this right here is our graph of our solution, which we found algebraically there. So let's try another one. And I'm having a hard time getting those just where I want them, aren't I? Okay. Everybody? Okay, we're going to subtract 4 from everybody. -6 less than or equal to -3x less than 1. Divide everybody by -3. Ding, 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 ding. 2 greater than or equal to x greater than -1/3. We've got to get it in the right form. Well, x always stays in the middle, so you just pick that guy up and turn it completely around. So -1/3 is down here, and 2 is down here, and check it. Is this the smaller number, and is this the larger number? Yeah. So now we got to worry about our signs. Well, when we compare -x and -1/3, I see that the arrow points at the -1/3, and it has no equal sign with it, so it's just up here it's greater than, so down here it's going to be less than. And then when we compare the x and the 2, it points towards the x, so it's going to point towards the x, but there's that equal sign with it, so we're going to include it there, and that is our answer algebraically. Real briefly, let's graph this. What are the only two numbers we care about? -1/3, 2. X lies between there, so that what we want on our graph should be all of the numbers between those, and then we just have to decide open or closed. So at 1/3 we have less than, open, and at 2 we've got less than or equal, so it is closed. Okay, that is it for this video. I will see you in the next one.